when you're dealing with trigonometric functions, signs can be a problem. I mean, it doesn't even have to just be trigonometry. It could be algebra, calculus, whatever. I know for me, it's really easy to get one wrong sign and it blows everything else up. And you're just like wondering, what am I doing here? So when it comes to trigonometric functions and their values and their signs, there's an easy little acronym to help you remember. So if we take the quadrants like this, keep in mind that we start here at 0 and we go counterclockwise around this. Remember the acronym, all students take calculus. And these will tell you which of the three main trigonometric functions are going to be positive. So I'm just talking about sine, cosine, tangent, because if we want to talk about the reciprocal ones, they'd have the same sign. If you turn a fraction upside down, the sign doesn't change. So here, this means that all of the three main trigonometric functions are going to be positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only the cosine is going to be positive. Now, since we're also talking about how we have the connection with the reciprocal functions, if sine is positive, that also means that cosecant is going to be positive. Tangent's positive, that means his reciprocal cotangent is positive, and cosine means that secant is positive. So, all students take calculus. Go in that order, starting in quadrant 1, quadrant 2, 3, 4. So let's look at some examples here. And I just want to make a quick little chart. This might make it a little bit easier for us. So just do this. Lovely chart, right? So here's what I want us to do. I want to find out if, given a certain theta, what will be the sign for sine, cosine, tangent, and then for cosecant, secant, and cotangent. So starting with this one, 79 degrees. In order to answer these questions well, you need to know where they are on the xy plane. So 79 degrees, just draw a quick xy. Here you get 0 degrees here, and this is 90 degrees, so this guy falls in quadrant 1. It doesn't really matter exactly where he is, it's just the fact that he's in quadrant 1. And in quadrant 1, that's where all things are positive. So each one of these guys will be a positive result. I don't really care what the actual value is. I'm just concerned about us getting the right sign. That's what's important here. The next example is negative 14 degrees. So negative 14 degrees is going to be, since it's negative, that means we're going in a counterclockwise rotation. So negative 14 is going to be somewhere down here. Why isn't it beyond that y-axis? Because if we were to go down here, we could see this as being negative 90 degrees, and we're just here at negative 14. So in quadrant 4, only cosine is positive. So let's see, cosine is going to be positive. Also, its reciprocal function, so secant is going to be positive, and everything else is going to be negative. That's all we have to do. This last one is 232 degrees. Let's see, where is that? So we have 0, 90, 180. Let's erase that right now. And then this would be 270. So 232 degrees is somewhere around here. Again, I don't care exactly where it is. All I care about is the fact that it's in quadrant 3. And in quadrant 3, you see here that only tangent and likewise cotangent are going to be positive. So tangent is positive, cotangent is positive, and then everything else for this will be negative. So there you go. It's a matter of understanding what quadrant you're in and remembering all students take calculus. All right, so we have some extra questions to talk about here. And it's just a matter of identifying which quadrant would satisfy the following conditions. So if I have that the sine of theta is less than 0, in other words, negative, and the cosine of theta is positive, okay? Draw a quick little chart. Remember, all students take calculus. So the question here is asking, where is sine less than 0? So I'm going to do this. Sine being less than 0, and again, try to start to connect sine with y. In other words, I'm asking where would y coordinates be negative? And that's going to be below the x-axis, and that's going to be down here in quadrants 3 and 4. And that should make sense because you see the ones that are at the top. You see the A, which means everything's positive, and S means sine is positive. But I want the ones where sine is negative. So that's why we go downstairs. And then where's cosine greater than 0? When you think cosine, you need to start thinking about x. Where are x values greater than 0? Where are x values positive? And that's going to be on the right side of the y-axis. So it's going to be here where everything is positive, and also down here in quadrant 4 where cosine is positive. So the question is asking, in what quadrant can you have a sine value be negative but a cosine be positive? And that's going to be, whoops, that's going to be in quadrant 4. So we can, eliminate, we can see where they overlap, and that's the intersection is going to be the answer for this. The next one says, where is the tangent less than 0, and where is secant less than 0? All right, let me draw my little chart here. All students take calculus. All right, so I need tangent to be negative. Let's see. Well, I know it can't be in quadrant 1 and it can't be in quadrant 3 because that's where tangent is positive. So it has to be either here or down here. That's where tangent is going to be negative. For the other part, for secant to be negative, think to what secant is related to. Secant is connected to cosine. So if the secant is going to be negative, that means cosine has to be negative. And cosine is negative over here and over here. So the intersection of these two quadrants is going to be quadrant 2. So when you're in quadrant 2, tangent is going to be negative. Cosine will also be negative, which means that secant is going to be negative. All right, so next we want to look at the range for these trigonometric functions, and then we'll look at some additional identities. So stick around.